Welcome back to part 7 of our live training series here with our K24 Swapped Civic SI, tuning this on our EMU black system. So in this final tutorial, we're going to be taking a look at doing our flex fuel based tune, and I have a resolution for that cranking problem that we've experienced throughout all the rest of the tutorials. We have a lot to cover here. Let's jump in so we can check this out. Welcome back to our live training session here with our K24 Swapped Honda Civic SI. This training module, we're going to take a look at doing our cold start and warm-up enrichment tuning process. So we're on day 2 of our calibration with our vehicle here. We've let the vehicle cool down overnight, and now we'll find that our cranking fuel and the warm-up fuel that we have to add in to get the engine to run properly is going to be different than a warm engine. So we'll explore this in this tutorial. We're also going to undo some of our calibration strategy that we've developed in the last 2 previous tutorials doing our low and high cam tuning. We're going to have to combine the volumetric efficiency all in one table, the spark timing compensation all in one table, and the kind of variable cam adjustments all in one table. So we're not going to have 2 different tables that we bias between based on our VTEC engagement, which is disadvantage I really strongly feel with the EMU black. If you want to do a flex fuel based tune, you can't have both of these set up at the same time. So we're gonna have to undo some of this, and we'll talk about that a little bit later in the tutorial. And finally, if there's enough time in this training module, we'll do a flex fuel based calibration process and actually show what and how that process is going to go. It's pretty straightforward and simple working with the flex fuel tuning feature, but again, there's some things that we have to make sure are correct. So a lot of things to talk about and to cover here in this training module. Now, the very first thing I want to do before we go in and take a look and talk about our cranking fuel and our warm-up enrichment, I want to talk about how I resolved the cranking or starting problem that we're having in the last few tutorials. So we know we couldn't get a clean crank, fire, and run out of the engine. Sometimes it would fire up perfectly fine, and other times it would just crank over, kind of misfire, spit and sputter, and then eventually it would fire off. Let's talk about how I resolve this. So in order to understand what's going on and why this was all creating a problem for me, we have to go in and take a look at some data here. So I was logging some data. Now we know we were seeing the unexpected missing tooth generated here when we were looking at our errors. So we were seeing our trigger error, and it showed that unexpected missing tooth. And we don't have any missing teeth on this particular trigger pattern. It's a 12+1. So it was problematic, and that was creating essentially all of our problems. Now, how did I resolve this? Well, I started to log and look through a bunch of data, and I noticed that we have our parameter here, cam sync trigger tooth. We can see it's pulled up here on my window. Now this cam sync trigger tooth is related to allowing the engine to actually sync up and fire and go through the normal pattern that we're programming in our trigger, so the primary trigger and our secondary trigger parameters that we're working with here. So what we're finding is that we have 24 total teeth plus 1 if we're looking at a total cycle in the auto cycle. When the EMU black is counting everything, it should see, and it counts between 0 to 23, so that's a total of 24 total teeth. It should show this cam sync trigger tooth here under cranking go from 0 up to 23, and that'll establish the sync, and then it'll allow the EMU black to fire up everything and get the engine to run properly. The problem that we were having is that cam sync trigger tooth was not generating a 23 count value for this pattern, which was the reason why we were getting this erratic starting. We could actually take a look down here in my plot window. I logged as I was changing things and updating and trying to experiment with some of my settings here in my primary trigger to figure out what this issue was caused from and how to resolve it. So we're seeing here this cam sync trigger tooth. Again, it should go from a value of 0, and as soon as we start to crank over the engine, it should go to a value of roughly 23 and stay there. That'll give it a steady state type of cam and crank pattern, enough for the EMU black to sync up properly and fire off the engine. Now we're finding here, as I'm cranking it over with the settings that I had in that base file, going in here, we were seeing it go from 0, and we see a value of 9. We can look down here in our window, we see a value of 11. Cranking it again, we see 16, we see go up to 23, and 23 is what we actually need for the engine to fire off. But in this case, I was just cranking it real quick and I wasn't getting the engine to fire. Now what we're finding here is that the parameter that's responsible for this issue is our cranking gap detection scale. This value was previously at 100%, and normally we don't need to touch this or adjust it. However, because this engine is high compression, it cranks a little bit slower than what the EMU black is expecting. And as a result, it was generating that unexpected missing tooth. Now, I haven't ran into this before with a K-series engine on EMU black, so there's a first for everything, and this is something that I had to go in and actually adjust. So I ended up adjusting it from a value of 100 down to 70 purely by trial and error. If we go across this data log, I was starting to experiment with lowering the value down. So with a high compression engine, if you're getting issues with this cam sync trigger tooth not essentially jumping to 23, well, that's going to be what you have to adjust. You have to go in here and start to reduce down that cranking gap detection scale. So we can see right here, I lowered the value from 100% where it was previously at this point in the data log. I lowered it down to 90. And what we can find here is when I crank over the engine, it went to 18, then 11, and then it held 24, 23 throughout here, and the engine fired right up. Now it wasn't perfect, so I experimented further. And as we go along here in time, I was moving the values lower and lower, and I got to the point where I was getting a very, very consistent, we can see right here, it goes from 0, 11, 23, and the engine fires off perfectly clean. We're finding that by going down here and reducing the values again, going from 100, then it went to 90, then it went to 80, then it went to 75, then it went to 70, 70. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.